Hey, welcome back to chemistry, and welcome to your first assignment for this week, where we are looking at a variety of variables in relation to heat absorption. What we've done so far with this unit is we've looked at the structure of an Earthship house, and we've looked at how the three types of heat transfer have come into play with that design aspect, right? So, for instance, like why is the greenhouse at the front of the house? Why is there a dirt pile at the back of the house? And how does radiation, convection, and conduction all work together to keep the Earthship house at an even temperature despite hot temperatures on the exterior or very cold temperatures on the exterior and all the fluctuations with seasons and everything else, right? Now, we want to take a closer look at some of the materials that are specifically chosen for Earthship houses, and that deals with heat absorption, retention, reflection of light, and all those other good things. So, in order to start looking at that kind of stuff, we're going to do a gizmo. So, just an overview, you guys are going to do part A of the gizmo during asynchronous time. And then we as a class are going to finish up the gizmo by doing parts B and C. All right. So, you guys will get an email with your login to Gizmos. You go to explorelearning.com, log in, and when you click on the chemistry class, you should see the gizmo that's called heat absorption. We haven't done a gizmo in a while, so just a reminder, click launch, and that will bring you to the official gizmo that you're working with. If you have your screen set up like mine, it's super duper easy to run through this. Let's go ahead and get started. So some key vocabulary that you'll need to remember. If we're talking about absorption, we're talking about sun's radiation being taken in or being soaked in by a material. If we're talking about reflection, we're meaning it's bouncing off of a material. It's not being absorbed at all. It's being reflected back. We're also talking about radiation, which are the electromagnetic waves that come from the sun. They travel through open, empty space, and they eventually hit us, right? And when I say hit us, it means we are either absorbing it or we're going to reflect that radiation. Thermal energy, again, is the kinetic energy associated with the movement of particles based on their temperature. So, thermal energy can be transferred via radiation, and that's going to be one of the big ideas we talk about today. And the last big vocabulary word you need to know is what a greenhouse is. You probably have seen one, you've experienced one, you probably might even have one at your own house. Greenhouses are glass buildings that we use to help grow plants when the climate doesn't really allow us to. So now that we got some vocab out of the way, go ahead and go to the prior knowledge questions. 2 questions you need to answer. Is it usually hotter outside when the sun is low in the sky, such as in the morning or the very late evening, or when the sun is high in the sky around noon? So think to yourself, when is the hottest part of the day? And then the second question, if you want to stay cool on a hot sunny day, would you wear black or would you wear white? And then explain why you think that. All right. Once you have those done, then we're going to go to the gizmo warm-up. It says, in the heat absorption gizmo, a powerful flashlight can shine on a variety of materials. Right now, the way the gizmo is set up, we have white colored light, but notice that you can also change the color to red, blue, or green. For now, we're going to keep it on white. We can also change the light angle. So if I have it 90 degrees, that is directly above whatever material I am working with. But then I can also make the angle less, or meaning more to the side. All right. Other things with this gizmo is that I can heat up a certain substance for about 3 hours, I think is the limit. That time is going to show up here after I click play. During that time frame, again, I'm measuring how hot that substance will get. So there's a what is it called? A temperature probe here that will tell me my temperature after those 3 hours. Okay. The very last thing is that I have a variety of materials that I can choose from, including metal, wood, water, and then a wide variety of colored bricks. And then we'll get to the glass cover later. Okay. So the gizmo warm-up. Step number 1, drag the wood underneath the beam of light and go ahead and take, I guess this guy was actually back at like 75, right? Take a look at what happens when that light hits the wood. And what you're looking for is all of the light absorbed by the wood, or is some of the light reflected, or meaning does it bounce off of the wood? So you're going to look for if there's like a color change here that would suggest light is being reflected off. When you click play, like I said, that starts this timer here for 3 hours, and it's going to ask you to look at the temperature of the wood. Record some of that information here, and it's going to ask you about that absorbed light energy. What does that do to the wood? And you should be answering that in terms of like the wood is either absorbing kinetic energy, is it reflecting kinetic energy, like what's happening there. Okay, activity A. The big question with activity A, how does the angle of light affect heating? So in order to get the gizmo set up, follow the instructions there. It says click reset, double check that the light color is set to white, and then wood is already there, so we are good. It says drag the flashlight to several different angles. At what angle is the light being most directly focused or concentrated on the piece of wood? So if I bring the sun, it would be the sun kind of. If I bring the flashlight to the side, does it look like that flashlight is hitting the wood like head on, direct? Is it fully concentrated on the wood? Or does an angle more like 90 degrees give us a more deer in headlights feeling? Okay, so which angle would you choose is more directly focused on the wood? Then you form a hypothesis. How will the angle of light affect how much the piece of wood is heated? So as the angle of the flashlight increases, which means we go from an angle like 20 degrees to 40, 50, 60, all the way up to 90. So as the angle increases, will the piece of wood get heated more? Will it get heated less? Will it get heated faster? Will it get heated slower? Like there's a variety of ways that you could answer that question, but you make a hypothesis just to guess. Doesn't have to be right. Then question number 3 says, which angle will result in the hottest piece of wood? You can be pretty specific here and have a angle in your mind, like I think 75 is going to be the angle, or you could say something in general like smaller angles are going to result in hotter pieces of wood, or larger angles. Okay, so either which way, again, it's a prediction, doesn't have to be exactly correct. Take up your best guess. When you get to the experiment part in part A, it's asking you to change the angle of the light and figure out the final temperature. So in order to do that, the first angle is 20 degrees. Set the angle that it says in the data table. Then you're going to click play and you're going to let it run. The time is going to go up to 3 hours. What you're looking for down below is the final temperature. So that's down here in the left corner. The final temperature is 30.7 degrees Celsius. So in this box here, you would just write 30.7, okay? Then you switch it to 40 degrees. So you're going to hit reset, bump the flashlight up to 40 degrees, and then hit play. Let the timer run out till 3 hours. And then the final temperature there is 40.1. So you'd enter that into this box here. Okay. Once you've done that for all of those angles, number 5 says, why did increasing the angle of the beam of light cause the wood to heat up more? That was the pattern we saw. As we increase the angle, it gets hotter. But why? Why did that actually happen? Take your best guess there to figure out why. And then question number 6 is going to be an extension of your thinking, giving you a real life scenario. So like St. Louis during the summertime, like in the month of June, the noon sun rays hit St. Louis at an angle of 75 degrees. But in December, they hit at an angle of 28 degrees. So how is that going to affect the temperature of St. Louis on those different days? You can use the sentence starters to get you started with that. If you have any questions during this first part of the gizmo, don't hesitate to email me or come to office hours. Whatever floats your boat, what you like best is cool with me. Don't forget, we are going to do activity B and C in class. So you don't have to do this whole thing. Just do part A. Okay. I hope that helps you out. If not, again, email or office hours.